Hi, this is James Cook of the University of Maine at Augusta, and let's talk about betweenness centrality. This is a kind of social network measure for a node that is a little bit less intuitive than some others. But I hope through a few examples to help you start to see betweenness centrality as a concept that makes sense and as a measurement that you can accomplish. Let's imagine for the moment that we're not talking about abstract nodes and lines. Let's talk about communities, places. The cities of Allenton, Beaverton, Charville, Danvers, Edgerton, and Fluville. And imagine they exist on a map in some state, some place where you might want to go someday. Imagine that they're equally spaced, just to make it simpler, and that there's a series of roads connecting these towns. One between Allenton and Beaverton, one between Beaverton and Charville, one from Charville to Danvers, one from Edgerton to Charville, and one from Edgerton to Fluville. So, now we have some cities, and we have some roads. Now, let's imagine that you had the opportunity to be mayor of any of these towns. And as mayor, you would be involved in setting up trade deals. Which of these towns would you want to be mayor of? Well, you might intuitively not want to be the mayor of Allentown or Fluville. After all, they have no choice but to work through Beaverton for Allentown or Edgerton for Fluville. Any goods that are coming in have to go through Beaverton for Allentown, and so they're at a competitive disadvantage, a negotiating disadvantage. Edgerton is in between Fluville and Charville. So for Fluville, that's a pretty nasty spot to be in. Edgerton can exact whatever terms it wants if the Fluvillians want to get their goods to everyone else in the six-town area. Charville is doing a lot better. It has an advantage over Beaverton and Edgerton. It has many different towns that it can work with. Well, why does Charville have the best negotiating position? Because it's in between the most of the other communities. This notion of maximum betweenness, that it stands between all these other communities when there are roads along which trade might happen, is the very idea behind betweenness centrality as an important concept. So, how would we go about quantifying how between any community is, any node is, in this network? Well, we might go through and think, first of all, are there any sets of roads, combinations of roads, paths from one community to another in which a particular town lies in between any others? And in this case, there are 3 communities that are never in between any other communities on the road. They're always at some kind of disadvantage. That's Allentown. There are 0 paths that you can find in which Allentown is in the middle, in between. Fluville, 0 of them. There just are no paths that you can find, roads you can find from one community to another with Fluville in the middle, and the same is true of Danvers. So that's our first step in figuring out betweenness centrality. Then we might say to ourselves, okay, well, how many possible paths are there, trade routes between communities along which Beaverton sits in the middle? Well, there's one from Allentown to Beaverton to Charville, that's 1. Then there's Allenton to Beaverton to Charville to Danvers. Okay. Beaverton's in the middle of that, that's 2. In the middle means not on the end, right? Then there's Allenton to Beaverton to Charville to Edgerton, that's 3. And Allenton to Beaverton to Charville to Edgerton to Flewville. That's 4. So 1, 2, 3, 4. A betweenness of 4. What about Edgerton? Well, let's see. From Flewville to Edgerton to Charville is one route, one set of roads along which Edgerton is in the middle. Flewville to Edgerton to Charville to Danvers. That's another trade route for which the goods have to pass through Edgerton, making Edgerton important. That's 2. So Flewville to Edgerton to Charville to Beaverton is 3. And Flewville to Edgerton to Charville to Beaverton to Allentown is 4. So again, like Beaverton, Edgerton has a betweenness of 4. Wow. Now what about Charville? Charville is in between a lot of different towns. Most of these routes, a lot of these routes rather, involve Charville in the middle. So we could say, let's start with Allentown. Allentown to Beaverton to Charville to Danvers, that's 1. Allenton to Beaverton to Charville to Edgerton, that's 2. Allenton to Beavertown to Charville to Edgerton to Flewville, that's 3. Whew. Okay, now we can talk about Beaverton to Charville to Danvers, that's 4. Beaverton to Charville to Edgerton, that's 5. Beaverton to Charville to Edgerton to Flewville, that's 6. Okay, now Danvers to Charville to Edgerton, that's 7. And Danvers to Charville to Edgerton to Flewville, that's 8. 8 possible trade routes along which Charville is in the middle, which means Charville has a betweenness centrality of 8. That's really, at its simplest, all there is to betweenness centrality. But, of course, there are sometimes wrinkles. So let's imagine that in an effort to get around this centrality of Charville, when we have these roads set up, Flewville and Beaverton get together and they say, you know, why don't we go ahead and make a connection there? When we do that, we'll be able to get around Charville, and we'll be able to trade with each other and get to, you know, other communities as well. Very handy. What does that do to the betweenness centrality of Charville, of Flewville, of Beaverton? How does it change matters? And who wins in that new arrangement with the building of a new road? Well, let's go through again and ask ourselves, are there any communities here, any nodes in the network for which there is no betweenness? They're never between in any road. Yes, Allenton has a betweenness of 0. It's never in between. And Danvers, it's never in between. So that's a good start. Okay, what do we do next? Well, let's start thinking about Beaverton. Okay, so Beaverton is now going to be in between on some straightforward routes. Allenton to Beaverton to Charville. Is there any faster way to get through there? I don't think so. Let's try. Allenton to Beaverton to Charville. Beaverton's in the middle. Okay. What about Allenton to Beaverton to Flewville? Okay, that looks pretty good. Allenton to Beaverton to Charville to Danvers. 3. I think that's pretty good. Now, let's figure out a little bit more. We have some trouble. Allenton to Beaverton to Flewville to Edgerton. Well, that is a route that is 1, 2, 3 roads long. The network distance is 3. But it ties with Allenton to Beaverton to Charville to Edgerton. So if you were driving, if you were a trucker, and you were taking your goods from Allenton to Edgerton, right? Half of the time you would go Allenton to Beaverton to Fluville to Edgerton, and half of the time you go Allenton to Beaverton to Charville to Edgerton. So, in that case, for Beaverton, there are 2, right? 2 geodesics that are tied for the fastest to Edgerton, and Beaverton's on both of them. 2 out of 2, that means 1. 2 divided by 2 is 1, so we're going to count that there. Okay. So, that's good. Now, finally, we might think about people trying to get from Danvers to Fluville. Right? Danvers to Fluville. And Charville to Fluville. Right? We haven't considered those yet. Let's start with Charville to Fluville. You see, there are 2 ways to get from Charville to Fluville, and it's the same length, 2 roads. And they're the same length, you know, the roads are the same length. So a trucker half the time would go from Charville to Fluville, and half would be through Beaverton, and half the time would go from Charville to Fluville through Edgerton. So there are 2 geodesics there, and one of them takes you through Beaverton. Okay, so I'm going to make a little 1/2 there. Okay, and now we have to think about the same for the route from Danvers to Fluville. Someone would go from Danvers to Charville, and then half the time they'd go through Beaverton, half the time they'd go through Edgerton. So 1 out of 2 of the geodesics involves Beaverton, so we'll put another half there. So 1, 2, 3, 4 plus a half equals 5. Cool. What about Charville? Where does Charville stand in all this? Well, and we could do this again, right? Charville finds itself saying, every time someone wants to go from Danvers to Charville to Edgerton, Charville is always in between. There's only 1 geodesic. So we'll go 1. Every time someone goes from Danvers to Charville to Beaverton, Charville's in the middle. There's only 1 geodesic. That's the shortest path. 1. Every time someone goes from Danville to Charville to Beaverton to Allentown, that's the shortest route. 3. You can't get any shorter of a route. Okay. Now, what about getting to Fluville? From Danvers. Again, just like before, just like for Beaverton, we can look and we can say, well, let's see, you could start from Danvers to Charville to Beaverton to Fluville, or Danvers to Charville to Edgerton to Fluville. Each of those paths is 3 roads long, and so there are 2 of them. So 2 goes in the denominator on the bottom of our fraction, and there are 2 of those 2 geodesics that involve Charville. Oh, great. So we'll put a full mark there, 1. Now, finally, there are a couple more possibilities. Someone going from Beaverton to Charville to Edgerton, that works half the time, but half the time they might as well go from Beaverton to Fluville to Edgerton. So there are 2 ways to get from Beaverton to Edgerton, and only 1 of them goes through Charville. So we'll do a half. Okay. And finally, whenever anyone wants to go from Allentown to Edgerton, they can either go through Charville or they can go through Fluville, and the distance is the same. So for every 2 ways, there are 2 ways to get to Edgerton, and 1 of them goes through Charville, so we do another half mark. So Charville, like Beaverton, has 1, 2, 3, 4, a half and a half. It has a betweenness centrality of 5. Whew. Okay, that's pretty good. Well, what about our last two? Edgerton and Fluville. Okay, let's consider someone who wants to go from Charville to Fluville. Half the time they would go through Edgerton, half the time they would go through Beaverton. So we're going to say there are 2 geodesics, and one of those 2 geodesics gets you through Edgerton. So we'll do a little half mark. Okay. And then what about going from Danvers to Charville to Edgerton to Fluville? Well, again, half the time you'd go through Edgerton, half the time you'd go through Beaverton. 2 geodesics, one of which is through Edgerton. 1 divided by 2, 1 out of the 2 is 1/2. No matter where else you're wanting to drive, Edgerton isn't between any of the shortest paths for any of the other towns. So a half and a half means Edgerton gets a betweenness centrality of 1. What about Fluville? Okay, to get from Beaverton to Edgerton, half the time you go through Fluville, half the time you go through Charville. Okay, 1 out of the 2 geodesics, a little half one. And finally, to get from Allentown to Beaverton to Fluville to Edgerton is one of the ways to get from Allentown to Edgerton. The other one is to go Allentown, Beaverton, Charville to Edgerton, right? Those are the 2 shortest ways to get to Edgerton. One of the 2, 1 out of 2, 1/2 of them goes through Fluville. So another little mini half. A half plus a half is 1. So Fluville has a betweenness centrality of 1. Okay. That looks pretty straightforward. Can you figure out the betweenness centrality for each node in this network? How about this network? Pause the video, and then I'll come back and we will do a little figuring. Pause now. Okay, did you figure some of these out? Some of these nodes are pretty easy to figure out. Let's take node A. Node A there is not on a shortest path from any of the other nodes to any of the other nodes. If B wants to get to C, why should it go through A? It can get to C more quickly. Same goes for D, E, and F getting to any other node. A is not on the path to shortness. There is no geodesic for which it's in the middle, for which it's in between. Its betweenness centrality is 0. F is in the same position, 0. Now, interestingly, if you think about it, for B, C, D, and E, you'll notice that structurally, in the structure, they're in similar positions, just like A and F are, right? Meaning they are each tied to 2 others in a square and to 1 other in a triangle that's headed off, right? They're interchangeable structurally. So if we just figure out the betweenness for one of these nodes, we can figure it out for the others. Now you could go through figuring out the betweenness centrality for B, and then figuring it out for C, and then for D, and then for E. But I'm going to do the shortcut. I'm going to notice that B, C, D, and E are structurally equivalent. They're in the same place in the network, structurally speaking. So for B, there's one contribution that's pretty straightforward. If you want to go from A to D, the shortest way to do that is through B. So we're going to give them 1 credit. And, well, what about getting from A to F? Well, you could go A, B, D to F, but you could also go down at the bottom, A, C, E to F. There are two shortest ways to get there with a network distance of 3. And one of them is through B, so we'll give half credit for that. And what about trying to get from C to D? There are two ways to do it. There's no straight path from C to D, but you could go C to E to D, or you could go C to B to D. Two ways to do it. One of them is through B. 1 out of the 2. 1 divided by 2 is 1/2. We'll give half a credit there. And then we add all those chits up, and that equals a betweenness centrality of 2. If you do the work, you can figure out that D also has a betweenness centrality of 2. C has a betweenness centrality of 2. E has a betweenness centrality of 2. I hope these examples have helped you think about, in a very practical way, such as travel through towns, what the advantages are of being in between, say for trade. And more abstractly, figuring out what betweenness centrality can be by looking at geodesics, counting them, and thinking about the minor complication of having to share the pride of the shortest route with another path.